Hello everyone. We'll start with laws of motion today. So in this, firstly, you have to understand what is force, right? So force is a push or pull on an object. Force is a push or pull on an object which which changes which changes the state of rest, motion, or direction of an object. Okay, so force is a push or pull on an object which changes the state of rest, motion, or direction of an object. Okay, so the SI unit of force is Newton and it is represented by capital F, right? So it is represented by, we can write, it is represented by capital F and its SI unit is Newton, right? And it is represented by capital N we have. So, and force is equal to mass into acceleration, right? Mass into acceleration. So this capital F, as we know, this is the force. This capital M is the mass, and this capital small a is the acceleration. Okay, so now we have what are the types of forces, right? So we'll study about the types of forces now. What are the types of forces? So write down, we have first type in this is the contact force. Contact force. Second type we have is the non-contact force. Third type we have is balanced force. And the fourth type which we have is unbalanced force, right? Unbalanced force. So what is contact force, what is non-contact force, what is balanced, and what is unbalanced force? We'll see one by one. Okay, so see here, we have firstly the contact force. The contact force. So what is contact force? If there is a physical contact between the interacting objects, right, then that force is called as the contact force. So the force which comes into play when there is physical contact between two interacting objects, right? So that is what the contact force is. Now, what are the examples of contact force? Examples we have is the frictional force, right? So frictional force, for a frictional force, we must have the contact between the two objects, right? Then only we have the force, and that is frictional force. Second, we have what is called as the muscular force, right? That is, we push an object, we pull an object. Without a contact, we can't push and pull an object, isn't it? So that is the muscular force which we apply on that object. Third one we have is elastic force, right? Elastic force. So what is this elastic force? When we if we have a rubber band, if you stretch it, right, if you stretch it, what will happen? We have a contact between the atoms inside that the rubber, we can say, and we have a force, and that is elastic force, and etc., we can say, right? Now after this, second one we have is non-contact force. Non-contact force, right? So the force which comes into play without any contact between the interacting objects, that force is called as the non-contact force. So you can write the force which comes into play when there is no contact between, or you can write without contact between interacting objects, right? So this is what the non-contact force is. And what are the examples of non-contact force? Examples of non-contact force, you can write the gravitational force, right? So gravitational force, if I release this object, right, what will happen? It will fall down. Why? Because there is a gravitational force on this object due to the earth, right? So this is the gravitational force which we have, that is the non-contact force. As there is no contact between the object and the earth, then too it will experience as a force, that is the non-contact force, we can say. Then we have electrostatic force. Electrostatic force. So this force will act between the charged bodies, right? So we know the atom, right? In atoms we have the electrons, protons, right? So two electrons, if you place together, they will repel each other. If electron and proton is there, they will attract each other without any contact between them, right? So that is the electrostatic force, and that is also a non-contact force we have. Then we have the magnetic force. This we know, right? Magnetic force. So force between the magnet and the iron particles. Iron particles is the magnetic force, right? So that is the magnetic force which we have, and you can write the etc., right? Or else a nuclear force, you can add one more force, and that is nuclear force, right? So we have the four fundamental forces in the nature, right? Gravitational force we have, then electromagnetic force we have, the weak nuclear force we have, and the strong nuclear force we have, right? So that are the four fundamental forces. If you want, you can write in this only. So four fundamental forces in the universe. Fundamental forces. First one we have is gravitational force. Then we have second one. Second one, the electromagnetic force. Third we have is weak nuclear force. And the last one we have is the strong nuclear force, or else you can directly write nuclear force. Right. So the weakest force in the universe is gravitational force, which we have. Right. So weakest force, you can write weakest force in the universe is gravitational force. Right. So we have the weakest force is gravitational force, and the strongest force in the universe, strongest force in the universe is is the nuclear force. So do remember this nuclear force. Okay. So the weakest force we have is the gravitational force, and strongest force we have is nuclear force. Now after this, the third type which we have is the balanced force. Balanced force. So what are the balanced force? If net force on an object, if net force on an object is zero, if net force on an object is zero, then that force is called as, then that force is called as balanced force. Okay, so you can write here, if F net is equal to 0, if net force is equal to 0, then this force we have is the balanced force. So you can write example like we have, suppose an object. If I apply a force of 10 Newton towards right and 10 Newton towards left, so net force on this object of mass m will be 0, 0 Newton. Right. So here SI unit is Newton. So I hope this is clear now. Now the fourth type and the final type which we have is the unbalanced force. Unbalanced force. So what are the unbalanced force? If net force on an object, if net force on an object is not zero, then that force is called as, unbalanced force. Okay. So you can write here, if F net, that is the net force, is not equal to 0 Newton, right? So this force which we have is the unbalanced force, and example you can write like if body of mass m is there, and if I apply a force of supposed to be 5 Newton towards right and the 2 Newton towards left, the net force will be in the direction of greater force, and that is towards 5 Newton, and the net force has a value, and that is equal to 3. So this is F net which we have. So I hope this is clear. Okay, so after this we'll have the first law of motion, that is Newton's first law of motion. So write down Newton's first law of motion. So what it states is that if body is at rest, it will remain at rest. If body is in motion, it will remain in motion unless and until the external unbalanced force acts on that body. This is the Newton's first law, right? So you can write a body at rest, it will remain at rest. Remain at rest. A body in motion, it will remain in motion. Motion unless and until external unbalanced force acts on that body, okay. So this is the Newton's first law of motion, right? So it says if a body is there, right, if it is at rest, right, it will be at rest if F net is equal to 0, and if body is in motion, right, so it will remain in motion if F net on that body is equal to what? 0, right? 0 Newton you can write, okay. So you can write F external is equal to 0 if F external is equal to 0 Newton, if F external is equal to 0 Newton and U is equal to 0, body will remain at rest, and if U is equal to some velocity we have V, body will remain in motion. So I hope this is clear. So this is the first law of motion we have, and this first law is also called as the law of inertia, right? So this first law is also called as law of inertia. You can write over here this first law, that is Newton's first law of motion, is also called as the law of inertia. Okay, now what is inertia? We'll see. What is inertia? See, inertia is nothing but the inability of a body to change its state of rest, motion, or direction. Okay, so inertia is nothing but it is the inability of a body to change its state of rest, state of motion, or direction, we can say, right? So it is the inability of a body I'll give the example, so don't worry. Is the inability of a body to change its state of rest, state of rest, motion, uniform motion, you can say, or direction, right? So we can have the three types of inertia. Inertia of rest we have, inertia of rest. Second type, inertia of motion. And third type, inertia of direction, right? So these are the three types which we have. So firstly, we'll see what is inertia of rest. So the see here, definition will be very simple. It's really very simple. First one, inertia of rest. What is inertia of rest? It is the inability of a body to change its state of rest. That is it. Okay. Inertia of rest. What is inertia of rest? It is the inability of a body to change its state of rest. That is what the inertia of rest means. Okay. So I'm writing here. It is the inability of a body to change its state of rest. So this is what the inertia of rest. And what is the example? So let us suppose you are standing in a bus and bus suddenly starts. What will happen? Tell me what will happen? You will tend to fall right backward, isn't it? So that is the inertia of rest. Why it will happen? Because see, your feet and the floor of the bus will be in motion, but your upper body will be at rest, and that is due to inertia of rest. Your body does not, or it will not change its rest to motion. That is the inability of that body, right, to change from rest to motion. That is the inertia of rest we have. Okay, so you can write the example. You can write the example like a body. If you are standing in a bus and bus suddenly starts, then you will tend to fall backward, isn't it? Right. So this is the inertia of rest which we have. Now after this, we have the inertia of motion. So second, write down inertia of motion. So you can write in this, inability of a body to change its state of motion, right? State of motion. That is what the inertia of motion is. Example is same. Now if you are in a moving bus and driver of a bus applies a brake, what will happen? your body is in motion, your body does not want it to change its state, that is motion to rest. So what will happen? You tend to fall forward now, right? So that is the inertia of motion we have. Now here in this case, your upper body is in motion, right? Floor of the bus and your feet will try to come at rest, but your upper body does not want that, isn't it? So that's why we will, or you will fall forward, right? So that is the inertia of motion. So you can write example, if you are in a moving bus and driver of a bus applies a brake, what will happen? You will tend to fall forward. So I hope this is clear. Right, so this is the inertia of motion we have. This is the inertia of motion we have. Now after this, we have the inertia of direction. Third type, and the last type we have inertia of direction. Definition is very simple, same thing. Inertia of direction. So in this you can write inability of a body to change its state of rest, state of direction, right? State of direction. That is what the inertia of direction is. An example also very simple. If you are on a turning road, or you can say you are on a circular road, what will happen? What will happen if you are over here? You will feel a force outward, isn't it, towards the window, isn't it? So that is you can write in this, if you are on a turning road, turning road, then you will experiences a force outward, right? So this is the example of inertia of direction. After this, we'll take momentum, and after that we have Newton's second law of motion. Newton's second law of motion will continue in next session. So firstly, we'll complete this now today, and Newton's second law of motion I'll take in next session. Okay. So write down momentum. Momentum. So what is momentum? We have quantity of motion, quantity of motion present in a body, right? Quantity of motion present or contained in a body is called as momentum, right? Momentum. Like if I have a pen, right, and this velocity of this pen is 0, what is the momentum? 0. Why? Motion is 0. That's why. So whatever quantity of motion, mass along with velocity is important, right? Mass along with velocity is important. So that's why momentum is mass times the velocity. So quantity of motion present in a body is called as momentum, right? So you can write here momentum, and it is represented by capital P. It is are represented by capital P, and its mathematical expression you can write P is equal to m into V. So you can write momentum is the product of mass and velocity. So this is P, and that is we have the momentum. This is M, that is we have the mass, and this is V, we have the velocity. Okay, so momentum P is equal to mass times the velocity. So see here we have, let us consider, I'll take an example of it. And we have, let us suppose, a body of mass, 10 kg moves with velocity 5 meter per seconds. Now we have to find what is the momentum. Find momentum of the body. So see here, momentum, we know that momentum P is equal to mass times the velocity. Here mass is 10 kg and the velocity over here is 5 meter per second. So 10 into 5 is 50 kg meter per second. So it is that simple, right? So we have momentum, and that is 50 kilogram meter per seconds, right? So this is all about the today's session. So I hope this is clear, and thank you so much everyone.